Hello and welcome to Cloud and 5G Live. We've got some amazing content lined up for you today. Right now we've got a fireside chat entitled Edge, and joining us to discuss this topic we have Samer Gesaya from TELUS and Neetu Kaushal, who joins us from Accenture. Samer is the Director of Technology Strategy and Architecture at TELUS. He holds a Stanford Lead Corporate Innovation Certificate from Stanford University Graduate School of Business, as well as a Bachelor's of Science in Computer Engineering and a Bachelor's of Science in Computer Science from North Carolina State University. Neetu, who is the Managing Director of Intelligent Edge, is a strategic business development leader at Accenture, driving the Edge practice across Europe with a total of 63 countries and based out of London. With over 20 years of global telecoms and technology company experience stretching across IoT, edge computing, big data, and AI, she has regularly managed business units with revenue lines of more than 1 billion per annum. Neetu has been awarded Top 35 Females Award at Vodafone Group Enterprise and the World's Top 50 Edge Computing Influencers 2019 Award for her work in technology. Please welcome both Samer and Neetu to the stage. Hi Samer, hi Neetu.
Hi, how's it going?
Hello.
Brilliant, thank you. How are you?
Perfect, thank you so much. Great to be here.
Good stuff, good stuff. So without further ado, I'd like to get the discussion going with our first question, which is going to be to Samer. Sorry. Firstly, Samer, what would you say is an easy definition of edge computing?
Well, it's an interesting question because it's one of those terms that has been getting a lot of hype these days, and it's very interesting when we talk to partners and we talk about use cases that anything from like an Arduino board, a single sort of core processor that happens to be processing some sort of load towards the edge of the network, to a hyperscaler like 2-3 racks full of equipment is being called edge computing. So of course, the standards actually define clearly what a multi-access edge computing is and what is the difference between that and a standard off-the-shelf application that happens to be running at the edge of the network from an edge computing point of view. I think what makes multi-access edge computing from a standards point of view interesting is it leverages the strength of the mobile network and the network application functions within the mobile network, which give a combined effect that not just that you're cutting the latency, but you also have access to APIs that will empower your application. And the rest of the quality of service parameters, whether it's jitter and many of the other quality of QSI indicators, these can actually complement by providing in the future with 5G technology dedicated slicing. Now, from a start, it's basically the opposite of hyperscaler cloud aggregator. Historically, hyperscalers were actually very brilliant. 10 years of experience of aggregating servers in a big data center that everybody's data is on. But that has proven that it's not very beneficial when it comes to applications that require responsive network decisions, so that you don't want to go back to the application, the server application, make a decision and come back again. That round trip time is way too long for certain use cases. So that's when pieces of that big data center started to break off and get closer to the user, and hence closer to the far edge of the network, which is called edge computing. And that round trip down now becomes a bit closer because you don't have to travel through multiple hops in the network to reach the centralized cloud. You have a smaller edge compute network or a multi-access edge compute network that resides close to the end user and to the core of the network, hence leveraging the benefits we talked about. So that's generally what, in my eyes, an edge computing versus multi-access edge computing difference is, and it's an exciting place to be in, because now we're starting to see lots of use cases, as we'll talk about in the next few minutes about the use cases.
Brilliant, thank you. That's really, really interesting. Now, Neetu, my next question is to you, and I'd like to ask you about some challenges, if I may. And so, what problems does edge computing solve, and what are the challenges of using or implementing this type of technology?
Thank you, Sam. Just building on Samer's definition of edge, I concur with everything he said. The topic of location really matters with edge. That's the core kind of common denominator for us when we're thinking about any solution topology for our clients. But when we think about challenges, it goes back to what is edge in the first place. Edge is about collecting data, processing and analyzing all in real time. So it's really where milliseconds matter. So when we start thinking about what types of challenges happen, what types of use cases are firstly going to be enabled with something like this, because then that helps you see where the challenges come in. I mean, think about car accidents never happening again, because cars are either talking to lighting infrastructure or traffic infrastructure, or even talking to each other. Think about workers being safe in the environment that they work in permanently. There are no issues there. Think about the best consumer experience that you could ever have in a retail store, where you get to have what you want when you want, and your supplies are there as of when needed. So whilst these use cases are really great in terms of enterprises even knowing what edge is, I think that's one challenge in itself, because I think the market awareness hasn't quite reached the stage that some of the hyperscalers have already got to over the last 10 years. So there's a stage that we're entering here in terms of market awareness. And when our enterprises do understand what edge is, and they've caught up with what the technology could potentially enable them to do, then understanding what technology stack will then be leveraged to enable that is also quite confusing, because it really depends on the use case. And I've articulated a couple there, but you can see in some cases the assets are moving, in some cases there's a still environment, but it's a highly dangerous, or there's hazards there. So the environment then dictates what type of technology is going to be needed, whether it be in the actual device. So is there a bit of processing in the camera, or is it then going to be on premise in a warehouse or a manufacturing plant, or is it going to be in the far edge within a micro data center, or are you then going to leverage edge in the network, where we might be coupling edge compute basically in the 5G core network. So deciding how you then build that solution topology to support your use cases then becomes what I see as one of the challenges, because there are many ways to serve these use cases at this stage. So we are here at a stage where we're educating the market. We're really working closely with our clients to fine tune exactly what solution will help them achieve the outcomes they're looking for.
Brilliant, thank you. That's really, really insightful. Now, going back to Samer, you've given us a brilliant definition of edge computing, but what benefits does it have over other methods such as cloud computing?
Yeah, I think Neetu touched on this as well. So, and very true in terms of the challenges, visibility, understanding, a seamless onboarding process once you identify that you need low latency. But she also touched on some of those in terms of, what you could do on the edge, you can probably still do on the cloud. The difference is now you have the possibility to run a dedicated load with extremely efficient latency. That means you make your decisions quickly. So where this is going to be useful, we're gonna see a lot of those is, for example, in the video analytics domain. So Just to give you an idea, we as TELUS have partnered up with a company called Mayo Vision. And one of the things Mayo does very well is actually cut the cost of deploying sensors for cities that detect traffic at the traffic lights. So at the street traffic level, the traffic lights are controlled via sensors. What Mayo came and did and said, we just need a camera, like a 180 fisheye camera, goes on top, it sees all the four corners. As soon as we use video to decide a car has come across and stopped, that's when the timers for the camera for the streetlights need to get triggered. So instead of sensors, that was a very simple idea, but the decision to actually detect a camera, detect a pedestrian, detect an accident, detect an ambulance that's coming and turn the lights green, for example, these decisions need to happen in real time. And again, like Nito mentioned, some of our partners, some of our customers, their mission statement is based on zero accidents, like General Motors, for example. If you look at their mission statements, 0, 0, 0, zero accidents, zero emissions, and there's a huge focus on how that is gonna get done for every vehicle, not just General Motors vehicles. And that also fuels some of those use cases. So if you're able to use the low latency of the communication to take such decisions, video analytics use cases, whether it's for detecting vehicles, detecting an unseen pedestrian, cellular V2X standards are actually betting on low latency to be an extreme benefit to solving not just congestion, but also simple things like cutting emissions. Because you want to be able to identify objects on the road. You want to be able to identify potential unseen threats on the road, and communicate that to the larger ecosystem of users in the vicinity, and that can really only happen. So that's one side. On the entertainment side, there's lots of use cases where, again, we're seeing gaming, virtual reality, augmented reality use cases that again require extreme low latency, simply because the human body cannot process the delay in the VR and AR environment that causes nausea, for example. So we're seeing that a lot of those applications need to run very close on the edge, and those again find their way into manufacturing. We did a very interesting use case with a hospital where we actually fitted the medics and the ambulance with 5G headsets that are connected to hotspots, and those HoloLenses were actually helping the medics get support from the back end. They used to do this only using voice, but now they have a video and voice communication back to the emergency doctor. If they need some technical help to change an oxygen tank, if they have an unresponsive person that doesn't even speak English, they can get translation services on the spot. So a lot of those actually, once we prototyped and used them, showed the real strength of edge computing versus cloud computing, because it gives you that near real-time responsive network. And as mentioned, with the strength of the network now, providing quality of service indicator slicing, that combination becomes an extremely useful use case for a lot of vertical use cases in the industry.
Well, thank you very much, Samir. That's brilliant. Obviously, Samir, you've touched on use cases, and Neetu has as well. But Neetu, what would you say are the main edge computing use cases, or the major ones?
I get asked this question a lot. What's the killer application for edge? And I don't actually think there is one, because in every industry we're solving slightly different problems. And I think it always boils down back to the actual industry itself. So let's take retail industry, for example. It's been hurt by COVID-19 really badly. The way consumers are purchasing products has considerably changed. So the way that Edge can support, say, the retail industry is really around cost reduction. It's about selling more. It's about getting the right products on the right shelves at the right time when the right customer gets there. It's about monitoring all of these events. It's about getting the best customer experience that you can when you do go into store, because nowadays you can have a great online experience with some excellent delivery to couple that. So that building that in-store experience so that your customers keep coming back and you get to learn more about them becomes hugely important. So, that whole consumer experience, getting that consumer data, coupling it with the in-store experience becomes really important. So those live events that Edge technology can enable becomes really important there. And a lot of our grocery store clients are working heavily with us because there's repeatable purchase of items, and how you create that best experience for consumers is becoming a really hot topic right now. What I would also say is then with the quick service restaurants has been really interesting, because people used to go away and do drive-throughs, but how do you get to order on apps, and how do you get the restaurant experience plus the drive-through all in one has been a real revolution for the quick service restaurants. Just general basic things like stock monitoring on shelves, linking it back to your own warehouse and then back to your own supply chain so that you have full end-to-end transparency becomes really important. So now you're only purchasing the goods that you have demand for, so that forecasting of demand and supply becomes a lot tighter, I would say, in a supply chain environment. Some examples around manufacturing, I would say, is really around quality inspection. So making sure that every single product that comes off the conveyor belt has been built to the highest quality. And if there are defects that have been spotted, then how can they be rectified in real time so that you're not losing products as you're shipping them out to your customers. There's a lot around predictive maintenance, around machinery, broken parts. And, IoT has already done a fair amount there in terms of monitoring different component parts, but then bringing that together to actually rectify these together, along with reducing the defects on your production line, together becomes a real cost saving and operational saving for our client base. So together with all of those different incidents, what you've done is you've essentially increased the amount of data that needs to be processed in real time, and it warrants the need for edge technology. Other things, particularly around we talked about retail, we talked about manufacturing. There's plenty of things happening in the healthcare space as well. So building those best experiences for patient care in hospitals so that they can have the right equipment at the right time. And there's not a waiting time for either beds or equipment. We're starting to see a lot around mobility, building digital twins to do simulations so people can actually practice and understand exactly what type of surgical procedure they're going to carry out before they have to do something in an emergency situation. So there's a variety of different use cases here, but we're working very heavily in the space of process automation, where there are repeatable steps that need to be carried out. How do you get to improve those for businesses so that they're not making mistakes? And if there are mistakes, they're being rectified in real time. So we're seeing huge amounts of impact being made there.
Fantastic, thank you, Neetu. I'd like to move the conversation on now to talk a little bit about 5G. So, Samer, I was wondering, why does the fifth generation network need edge computing?
Well, I think one of the unique things I learned about the standards of 5G, which is it's one of the first few instances where the technology actually was, I don't know if that's a real term or not, but design thought. They used the principles of design thinking to actually come up where the standards actually need to go. Previously, if you recall, 4G, like 3.5G, 3 3/4, same thing with 2G. It was sort of like, what can the technology do? And then let's go there, right? And okay, can we squeeze in another few hundred megabits here or there? With 5G, in my eyes, it was very use case driven. Like, we understood there's going to be a massive need for IoT devices, but they need to last longer in terms of battery. They need to, be efficient. Some might need very low, like with narrowband IoT, so low bandwidth requirements, and some require maybe higher bandwidth, like LTE and LTM, etc. So having said that, 5G offered 3 or 4, I would say, technical solutions that complement some of what we saw: massive deployment of IoT devices, faster throughputs, and then the other bits, which are the density devices, right? So you can 10 times what you could carry within the cell site than we used to carry on 4G, 10 times the speed. That's great. Low latency comes in so that the optimized radio transport and core now also is optimized for latency and jitter and other quality of service parameters. So that adds to the capabilities of MEC, so that the rest of the network, also the round trip times, are also optimized. So now 5 milliseconds is what the network can do without even MEC. And MEC comes in to actually add on top of that. Last but not least, as we mentioned, one of the very unique 5G standalone service options is the ability to create a slice, starting with some static slices. It has mobile broadband as a slice, a massive IoT slice, and so on. What you see there, an ultra reliable low latency slice, and what you see there is there a combination of quality of service indicator parameters that give a dedicated quality of service to those specific SIM cards within that slice. So in case you walk, for example, downtown Toronto during a celebration of a hockey cup or next NBA title, your devices on those slices will not be affected by the generic transport core and radio resources that are dedicated to the other use cases, right? That gives you a sort of virtual private network across all of the network resources and not just on one side. So I think that combination really offers a very unique proposition that the telcos can actually offer edge compute solutions combined with the strength and dedication of the quality of service parameters that no one else can offer. And if you look at the potential number of locations where edge compute services can actually be hosted, we have thousands of sites, and if you know Canada's geography, it's a very spread country, but we have thousands of locations covering 95% of populated areas in Canada, and hence that potentially could be where your edge compute application can also run if need be, right? So you need that sort of very extreme low latency combined with the network strength of quality of service indicators and slicing. Then you have a combination that offers and that's what we as TELUS have committed to do. Knowing some use cases that Nito described, all the way down to like near real time, use cases. We wanted to see in a 10-year roadmap, what is the number of locations we need to create? Because as you mentioned, we also need to distribute our core. Like just simply putting an edge compute server somewhere is not going to be a solution. You actually have to marry them with how your core is distributed. So UPFs are going to be spread across a number of locations that resemble the need for low latency at the edge of the network. So that's where I think the strength between 5G is a strong enabler for edge compute use cases, specifically multi-access edge compute implementations.
Brilliant. Thank you, Samir. That's fantastic. I'd like to talk now about something that kind of goes hand in hand with 5G, and that is the Internet of Things, or IoT. And Nitu, how does IoT relate to edge computing?
It's really simple for us, Sam. We're thinking that IoT is all about connecting assets. So it's a form of collecting data, Whereas edge computing is about smarter ways of processing that data that's just been extracted, applying some intelligence and building some decision-making models that act in real time. So I see them to go hand in hand together, and just linking this topic back to the advent of 5G. As the new network becomes more and more available, there's going to be more 5G based devices that become available in the marketplace. And I think this is really where the Internet of Things is going to grow in 10, 100 folds time, because there'll be so many more different types of assets and devices that we'll be able to connect to. So that means there'll be many more use cases that we haven't even imagined will start to become available. So this is where I see the industry to become quite exciting over the next 5 to 10 years.
Fantastic, thank you. That's really insightful. Now, finally, thanks to our wonderful audience, we have our Q&A session. And the first of these questions is to Samer. And it's, what's the difference, Samer, between edge computing and MEC? Again, from a developer's point of view, if you could sort of give us some insight on that.
Yeah, interesting question, because we talked about edge computing from a customer point of view and an operator point of view, but developer is actually providing a very unique view. So it's, developers for applications already been used to the various CI/CD tools that they use to deploy their loads on public cloud, and when they're ready to deploy their applications in private Mac or public Mac instances, the change in their tooling won't be very much. Like, be exactly a different address if they're using a telco public cloud or a telco private implementation of Mac or edge computing. The difference is going to be that in a lot of, once you start talking about 5G based applications, they're specifically if you're going to utilize slicing, that you're going to start to embed the network slice indicator in your applications, and the standards are actually starting to show that in that there is an added advantage if you start coding your application to be slice aware. So you can actually drive that from an application point of view to give your application the best environment. So let's talk about a connected vehicle for a second. A connected vehicle may use telematics or navigation apps that may require specific bandwidth, but nothing special. Let's say that's slice number one, just giving dot on a map. So here's where I am. I may need to update and refresh my maps every now and then. So I utilize specific bandwidth and download and give my location upload so that I refresh it in the manufacturer's database. But if cellular V2X use cases are deployed, now you want even a stronger location, much more accurate location service, which network can provide. You want to marry that with a specific quality of service indication that gives near real-time decisions. If I am driving my vehicle and I detect an object on the road, that message can be transmitted through the network back to the surrounding vehicles in real time. And to do so, you need to be coupled with a network slice and an edge compute application runs on both vehicles, all vehicles in the future, right? We actually did a very similar use case with the 5G AA in Virginia, where we actually shipped down a SIM card, a SIM profile from TELUS that is roaming in the US with our partner network, Verizon. And then the use case we just described, but it was a pedestrian walking behind an obstruction, so the vehicle does not see the pedestrian, but the network infrastructure camera we talked about can see the pedestrian. It actually, in real time, notified the vehicles in the areas, be careful, this vehicle is about to hit somebody it cannot see, and cause the vehicle to slow down. So these are no longer theoretical paper exercises. These are things that we're actually testing out in the field. And developers, the sooner they learn about these open standards, what they need to do, and lots of information on the and the 5G domain, and also technology forums such as the GSMA sponsored Operator Platform Group and Telco Edge Compute. These are all offering a standard on-app sort of how to begin with edge computing and multi-access edge computing application development impacts, but it's not going to change a lot from what you're already doing with your basic application. You have to think and engineer how much of my loads is going to be needed on the edge for real-time decisions, and the rest of the database storage, etc., need to be divided in the normal traditional cloud storage to optimize your load. So it's a journey, but I think lots of learning now, and it's exploratory, and we offer some of our innovation hubs as well. So we as TELUS actually deployed about 4 innovation hubs to basically issue challenges, customer challenges out to the developers and to the larger SME markets, and address those challenges with and offer a lot of learning how to build 4G and 5G labs for them to run their loads and test them. So a lot of operators globally will also be able to help you with their own APIs.
Brilliant, thank you, Sameer. Unfortunately, we have actually run out of time, so we won't have enough time, unfortunately, to ask a question to you, Neetu. But thank you very much both for joining us for this fireside chat. Unfortunately, we didn't have any marshmallows to roast while we were doing it, but thank you for joining us, and thank you to the audience too. But please make sure that you do stay tuned to find out more of the action coming up here at Cloud and 5G Live. And thanks again to both Sameer and Neetu.